Hello, thanks everyone for coming down. This talk is called Fail Fast, Fail Forwards, Learning DevOps. It's kind of about my experience of moving from a development-ish role towards a more DevOps-y role, and what that kind of is. My name's Sam Smith. I have 100% no relationships with the brewery. I don't get free beers. It really breaks my heart every time. So without further ado, brief background about my background, because this is kind of like a personal story, so I think it's useful to know where I come from. Then briefly who this is for. Then the meat of the subject is a series of unfortunate incidents. So I'm going to explain to you a number of incidents that have occurred whilst I've been learning in this more DevOpsy role, and try and pull out some useful lessons from that. So who am I? Right. My background is physics originally, went to university, that was pretty cool, did Python and C, quite bad at C, quite good at Python. I actually did a lot of molecular dynamics simulations, so modeling DNA, how it flexes, how it bends on supercomputers, that's really cool. Well, it sounds really cool, but actually what I did more of was statistical analysis of that, which sounds much nerdier, but is a lot cooler, I guarantee you. Then I went on to think, hey, I could do academia. I can't. I developed this hardware and software where you track these roundworms in 3 dimensions and you record it micrometer level, and that was really cool. And it's meant to be fully automated, with feedback loops and all the rest of it. That didn't really work. Computer vision is really hard, so I hooked up to a joystick that I hid under the table and lied. Oops. Then, my actual career, I moved on to working with LAMP stacks and writing HSE software. So this was very much the waterfall methodology. I was very siloed. I had to deal with the entire stack still, but here is this chunk of work for you. You will be the master of this chunk of work. You will work to these specs for 3 months and blah blah blah. Produce something at the end of it. I did feel very much like a bit of an island at the end of it. And I'm now currently a reliability engineer in the gaming tribe, so kind of SRE-ish role. That'll be talked about a bit later, not in this talk actually, but conversation about what site reliability engineering is, what DevOps is, blah, blah, blah. I'm also an on-call engineer, and actually for anyone that is an operations role, a DevOps role, a developer, I strongly recommend you go on call. Some of the most useful learning experiences about how your stack works is when you're woken up at 2 a.m. and then have to think on your feet about, oh man, so that MySQL database connects to that web server. In what way do I actually understand it? Do I understand the failure modes? And then going back to your colleagues the next day, guys, it really broke last night. Let's not do that again. I really don't enjoy being woken up. Okay, so who's this for? People that embrace change, because I think that's what DevOps is about. It's about embracing a different kind of thinking, a different mentality, and being open to things. I think it's for people that embrace challenges, because nothing's ever easy. Day in, day out, you're faced with different problems be it from product teams, be it from developers, be it from the operational point of view. I'm in a more operational-ish expertise here. But yeah, so you've got to embrace the challenge of being able to deal with different things day to day. And it's also kind of for the people that are in a kind of siloed role and aren't sure if this is what you want, because I guarantee you it's not. I'd like to hope I can convince you that it's not, but we'll see where that goes. And it's also kind of for people that enjoy hearing stories about someone else screwing up, because there's a couple of those in this. Please don't laugh too much. Importantly, you will break things. In the DevOps methodology, in the Agile methodology, you will break things. That is fine, that is normal. Preferable in pre-production, but it's going to happen in production anyway. Embrace it, because it's actually fine. It's genuinely fine. And what's really important is that you can deal with that under pressure. You can think about, okay, there is a problem, I can come up with a solution, and I can fix this. It might be tactical, it might be long-term, it doesn't really matter. But it is fine. You learn from your mistakes. So I don't know if any of you guys remember, but back in January, the end of, there was a fairly major GitLab outage where one of their on-call, I'm pretty sure it was one of their on-call staff. Basically, they were updating the database, and they accidentally deleted their production database, which led to GitLab being down for 24 hours. And their response to that, I think, is kind of the epitome of this. Like, no one's to blame. Like, it happened. They dealt with it. They were very open and transparent with their customers and the public about how they dealt with it. And the developer himself, like on his profile, is like, it's just like, it's one of his stars now. Like, yeah, I did that. I dealt with it. Oh well, it happens. So, first story. This is about breaking high availability clusters. So we have a high availability cluster in the gaming tribe. It was about 9 months ago, it was being accepted into service, AIS. The basic stack, 5-node cluster, number of different services running on it, but importantly, there's a Java application written in akka, which allows you to do quorum and like establish quorum within the application so that it knows which part of the application is in the majority. And there's also a Kafka message queue, which is balanced by Zookeeper, which again can establish quorums. So a quorum of servers in a cluster of 5 should always be 3. As long as 3 servers can talk to each other, they know they're the majority, they know they're authoritative, and they know that they should be the ones responding to requests. If you're ever in the minority of that, if you're one of the 2 server pair of the Singleton, you definitely shouldn't answer anything, because for all you know, you're working on stale knowledge, you're cut off from the network, you have no idea. The good thing about this is at any point we can lose a server, it doesn't really matter. We can lose 2, we'd best be fixing it, but we're still serving traffic, everything's still hunky-dory. And so we was having this incident, it's in daytime, someone comes over to me and says, right, the disks are filling up really, really fast because we just upped the traffic load to them. And they're going to break in a matter of about 10, 15 minutes. You're going to have to scrub some logs down, and then we're going to have to extend the disk, blah, blah, blah. It's like, okay, that's doable, bit time pressure, never mind. Didn't quite work out like that. So I broke the high availability cluster. I might have pseudo-randomly gzipped half the server, which is a bit embarrassing to admit, but suffice to say, when you use sudo, you should probably use sudo -s rather than sudo -i before you run your gzip commands. Definitely learned from that one. That's a bad thing. It broke in very interesting ways, and looking back on it, it's like, I have no way of deterministically determining which files should be gzipped and which should not. So I'm going to have to rebuild this, because, infrastructure is code here, and that's okay. There's some of the configuration for that server. Blank most of it out. You'll notice the disk sizes are now 320 gigs. They were 20 gigs when I got there. There's a reason they're that big. It's fine. It's code. Let's just rebuild it. It's a high availability cluster. Let's go. Type in some commands into Jenkins, some server, rebuild it. What site? Let's hit build. Crack that on. And then in our monitoring system, I see this graph. So this is the message throughput on the left-hand side, not massive, it's pre-production. That drop off there where it all goes blank, that's where, I hit rebuild. And then the server starts rebuilding, and the cluster doesn't respond to anything, and that bottom line there just goes on and on and on and on and on off this graph. Oh dear. And this was my immediate response because, hi, I've been in the company for 3 months and oh my God, everything is broken. I'm not okay with this. This is very, 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 very scary. Actually, it wasn't that major. It's not in production. The guy at GitLab, he definitely probably should have been feeling that. So we investigate this. First priority is incident response. We need to get things back online. Interestingly, it wasn't as easy as rebuilding the node and bringing it back into the cluster, which you'd have thought, okay, why has this happened anyway? Let's bring it online, see what happens. What we had to do was rebuild the cluster, bring everything down, and then bring everything back up again, which seems a bit weird. So we start investigating, it's not normal behavior. So we start investigating this further. It took several days of investigating, analyzing logs and testing failure modes in test environments. And what we actually found out was that in the initial configuration between staging and a live environment, akka was operating in what's called Singleton mode. So the cluster boots up and the first node online says, I am the authoritative source of truth. Like, without me, it's essentially, I'm the master, you're all slaves. So any other node can go away, but if this node goes away, no one can talk to each other. That's kind of scary for a production system that's meant to be high availability, meant to tolerate losses. And the actual solution was really easy. You just go into the config files and say, no, like, we want 5 servers and this quorum is 3, like, do not operate in Singleton mode. Bing, 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 update code. Oh, it works now. So that was interesting. Next story. I'm going to try to draw lessons at the end. On-call shenanigans. This is quite an interesting one because I wasn't involved from this one from the start. I got called out earlier the next day. So what happens is one of our secondary systems like ingest data that's output once a day, passes through a message bus, goes into a data store. And so it loses, its state's corrupted on a bank holiday, so on-call staff get called out. That should be fine. We keep snapshots of everything. On-call staff are very experienced with data restoration. It shouldn't really be an issue, a couple of hours to restore at most, depending on the database. Roll back to the last known good state, rebuild. Unfortunately, it was a Redis cache, and it was operating in-memory caching. So we, for some reason, have persistent state in memory, which is very much like building a sandcastle and then not expecting the waves to come crashing down later on. Like, at some point, your server will fail. You will lose your state. And unless that is backed up somewhere, you're not going to retain that, be able to restore that state very easily. So we have to rebuild this. At this point, we had 42 data files, each quite large. They had each representing like a day's worth of data that had to be replayed through the message buses because we had access to all these individual files by hand due to the way it was set up. I'll explain a bit more about why it was set up this way in a minute. That was going to take roughly 10 hours. Okay, this is going to have to happen. On-call staff start doing this. They get pretty far into it. Then at 3 in the morning, cron jobs kick in that hadn't been disabled, thereby replaying the next day's data file over the top, thereby corrupting the data all over again. This is obviously really not good for the on-call staff. They're kind of feeling the pressure now. So they start replaying the data again. And about 6 or so in the morning, one of the engineers accidentally replays the same data file twice, thereby corrupting state again. These things happen. Like at this point, this member of staff has been up for since the previous morning. It's now about 6 the next day. Like they're going to make mistakes. There's no two ways around it. And during this time, like we had other engineers on call that were making tactical fixes so that if you were using our site, you wouldn't actually know this was going on. Like it looked different to it did yesterday, but the data you needed was there and just a bit odd, maybe. So about 18 hours into this process, we took a conference call in the morning, and we had a couple of different avenues to take. One was that today was going to be a really busy day. Like we couldn't risk trying to replay data. So we made a number of tactical fixes to make it even less likely that you would know what was going on. In the meantime, we also decided that the data ingestion is really slow. Like we've got to do file after file after file. And that's really prone to error. So let's write some code instead. So a couple of engineers, including myself, we went away and we wrote some Python, because I love Python. So it took us basically about 60 minutes to write a script together, replicating business logic that would then sew all these files together, stitch them together, and add some numbers up, essentially. That was easy to write. It took us another 60 minutes to actually debug what was going on, because we've written this fast, there's going to be mistakes made. And then we decided later on in the day when customers wouldn't be paying that much attention, right, go, let's get this code out. Then it took 90 minutes to replay all this aggregated data back into production, get the site back to working. It was like, nothing ever happened. Unfortunately, this meant that the total time to resolution was 27 hours, which I think is the longest time from initial like incident response to full resolution that I've certainly seen in this company. But no one was any the wiser for it other than the engineers involved and management that have been escalated to. And I think what's important here is like we learn from these mistakes. So why this was written in a Redis cache was it was written as a minimal viable product. And it was really easy to piggyback off the existing Redis caches rather than having to build new infrastructure because this really needs to go quite soon. And so rather than setting up another Redis cluster or writing it in MySQL, we piggybacked. I'd have argued we should have made another Redis cluster, put it into store on disk, but lessons learned. Sometimes your AIS process isn't quite good enough. Like there is pressure to deliver something now, and sometimes you don't feel like sometimes you feel like, okay, we should do it now. And you all buy into should buy it now, and then something breaks and you all step back and go, well, we collectively made this decision, and actually collectively we should have made the other decision. So something in our collective process is broken down here. And actually the thing this is really important is because this is coming onto the C in like Andy's CAMs, is about culture. And it's about the culture of how you deal with these sorts of issues. There's also the reliance on manual effort and the mistakes made that led to this. That took up half the resolution time. Any system that holds state, you need an automated recovery process. Like, can't stress that enough. If you can't afford to lose something, don't leave it in memory. Again, simple things. Writing code on the fly, really, really, really fun. Don't recommend getting in a situation where you have to do it. It carries a lot of risk. Like if we'd have made some bad code there, like we could have been this for the long haul, 27 hours a week, mate. So kind of try and draw all this together. I think it's important when you're coming into sort of like DevOpsy culture, because that is what I'd call it, not a role, but a culture, is that you want to fail fast. And because you're failing fast, you're trying to fail forward in the sense that, right, we failed now, how do we make sure we don't fail again? Certainly in this culture, and as Andy pointed out on our staff diagrams, like we've grown massively in the past several years. And like the in-house knowledge has been spread quite thin. So new staff coming onto the ground have had to learn quite quickly. And there are time bombs and landmines where previous decisions have been made and you're not quite sure how or why. So you've got to be wary for that. But you kind of expect it in any rapidly growing system. Like code base is expanding at an exponential rate, and you cannot expect to understand all of it, how or why it was written. So in that case, like no one's to blame if a human makes a mistake, and that's important because if you feel like you've been blamed, you're not going to want to try and push the boundaries and experiment anymore. And you need to understand why processes failed. Like so, in our previous example, the process failed because we all accepted that this could be accepted as service as it was, and the risk wasn't so great. And we had a mitigation, which, as I mentioned, was a manual playback. But we shouldn't have really accepted that. We should have said, okay, while this is going into service, we need to automate this. We need in the background, like we understand we will fail, so let's get going forward and automate it before it does fail. And also, when things do go wrong, spread the knowledge. Spread it as far and wide as possible. Document everything. Like give talks to other staff members. Like in your post-incident responses and reports, like make sure as many people are involved as possible, because that way they will learn from your mistakes, and you won't make those same mistakes again. And ultimately, the most important thing is culture. A culture where you don't feel like you're being blamed for something when it goes wrong. A culture where you're fostered to talk to each other and learn from your mistakes is really crucial to the entire mindset of DevOps. It's like the difference between being an isolated silo that knows the entire stack and can produce in a month or two, to someone that day in, day out can deal with the challenge, deal with an incident, make things better constantly, and always be supported by your co-workers, even though you might not understand everything. And I kind of stress for myself, certainly in my formative moments of learning this sort of job role, that is the most important thing you can nail down. Like, find somewhere where the culture is good enough that you know that my mistakes don't matter too much. I mean, obviously they do, but everyone knows you're going to learn from them. Yeah, that's kind of me done.